Welcome to Riji. Now we are starting exercise 3E here. Exercise 3E. In this exercise, the first bit it is first bit, find the adjoint and inverse of the following matrices. Find adjoint and inverse of the following matrices. In the first question, what is first question? Is 2 minus 3 4 6. 2 minus 3 4 6. This is the matrix he is given here, and the solution for this one is here. Adjoint, first we need to find adjoint. Adjoint is nothing but adjoint. Here this is, I am considering this matrix is A is equal 2 minus 3 4 6. Adjoint is nothing but, just we need to, for 2 we need adjoint cofactor here. So if we close the row and column here, this is 6 here, for 3 this is 4 here, for 4 this is minus 3, and for 6 this is 2. And here we need to interchange the signs here, plus minus minus plus. Here if you plus 6 minus 4 minus of minus 3 plus 2, it will become adjoint of A. Adjoint of A, that is equal, this is cofactor, this is cofactor, this is adjoint. 6 minus 4 3 2. 6 minus 4 3 2. This is adjoint A, and here inverse we want. Inverse is nothing but, inverse is equal to A inverse, that is 1 by det A into adjoint A. Here first we need to find det A. Det A R is equal to mod of A, that is equal 2 4 ja 2 into mod of 2 into 6 minus 4 into minus 3. So 2 6 ja 4 into minus 3 here. So 2 6 ja 12, minus into minus become plus 12, that is equal to 24, modulus of 24. Here A inverse is equal to 1 by 24 into adjoint A, here 6 minus 4 3 2. This is the solution for the first question. Alternately I am solving the question. I am solving second question here. And the second question for this, in this bit, second question, cos alpha and minus sin alpha. Next, sin alpha cos alpha, sin alpha cos alpha. And solution for this one, here A is equal, given that cos alpha minus sin alpha, sin alpha cos alpha. Next, now here we want adjoint, first cofactor matrix. What is cofactor matrix? Here first close first we need to find the cofactor element of cos alpha, that is cos alpha, and close this one, this is sin alpha, and for this one minus sin alpha, and for this one cos alpha. This is cofactor. Now we need adjoint matrix. Adjoint matrix is nothing but changing of sign, plus cos alpha plus minus, alternately I am taking signs here, minus sin alpha minus of minus sin alpha and plus cos alpha. And if you write adjoint of A is equal cos alpha minus sin alpha and sin alpha cos alpha. And this is adjoint A, but here we want A inverse also. First we proved here adjoint A is equal to cos alpha minus sin alpha cos alpha here. Now we need to find A inverse equal to 1 by det A into adjoint A. 1 by det A is nothing but det A here. First we need to find det A. Det A or is equal to mod of A. Mod A, that is equal to mod of cos alpha cos square alpha minus of sin alpha into minus sin alpha minus sin square alpha, that will become sin square alpha. It is in the form of identity sin square theta plus cos square theta, that is equal to 1. If you substitute this identity here, this value modus 1 equal to 1 here. Now A inverse will become 1 by 1 into, this is the adjoint here, cos alpha minus sin alpha and sin alpha cos alpha. This is the final solution for this question here. And the next one, these two are 2 by 2 matrices here, and the next one is 3 by 3 matrix. The question is 1 0 2 and 2 1 0 and 3 2 1, 3 2 1. So here I am directly solving. Let A is equal here 1 0 2, 2 1 0 and 3 2 1. First I am finding cofactor matrix. Cofactor matrix is nothing but I am taking a big one. Next I am here for 1 we are finding cofactor 1 into 1 1 minus 0 into 1 minus 0, and for 0 2 into 1 minus 0 2 minus 0, and for 2 to the 4 4 minus 3, this is 4 minus 3, and for 0 2 minus 0 2 minus 0, and for 1 for 2 I am taking this is 0 minus 4 here, this is 0 minus 4. If you eliminate this row and this column, 0 into 1 0, 2 into 2 4, and for 1 1 ja 1 minus 6, 1 minus 6. Next for 0 eliminate this one, 2 minus 0, and for 3 0 minus 2, and for 2 1 0 minus 4, and for 1 minus 0. This is completely cofactor here, cofactor matrix. We are getting 1 minus 0 1, 2 minus 0 2, and 4 minus 3 1, 0 minus 4 minus 4, and minus 5, and 2 minus 2 minus 4 1. This is cofactor matrix. Now we need adjoint matrix. Adjoint of A, that will become changing of signs here, plus 1 2 1 minus 4 minus 5 2 minus 2 minus 5 1. Directly I am solving here. Here we need to find each and every element cofactor here, then we need to substitute here, and changing signs here, plus minus plus and minus plus minus and plus minus plus. So after applying here, plus 1 minus 2 1 minus and minus become plus, minus 5 minus 2 minus 2 minus and minus become plus 5 and plus 1. This is adjoint A, and here we are completed for adjoint. And next inverse, A inverse is equal 1 by det A into adjoint A. Now we need to find det A. Det A is equal 1 into modulus of 1 into 1 minus 0 and minus 0 into 2 minus 0 and plus 2 into 4 minus 3. Now 1 into 1 only, plus 0, this value will become 0, 2 into 1 and 1 plus 2, that is equal to 3, modulus of 3, that A is equal to 3 here. Now A inverse is equal to 1 by 3 into adjoint A here, 1 minus 2, 1, 4 minus 5 minus 2 minus 2, 5, 1. Here this is the complete solution for inverse of a matrix here. And the next question is fourth question, you can solve by your own, and it is also one of the 3 by 3 matrix. You need to find the adjoint and inverse of the matrix here. And the next question, second question is second question. If A is equal, if A is equal A plus IB and C plus ID and then minus C minus plus ID minus C plus ID and then A minus IB, A minus IB, A plus IB, C plus ID and minus C plus ID and A minus ID, comma A square plus B square plus C square plus D square is equal to 1, then find inverse, then A inverse is equal question mark here. And the solution for this one is, here A is equal, he is given A plus IB, C plus ID and minus C plus ID and A minus IB. Here ultimately we need to find the A inverse. If you want to find A inverse, first we need det A and adjoint A. If you want to find adjoint A, again we need cofactor matrix. After finding cofactor matrix, we need to find adjoint. After finding adjoint, we need to find A inverse. In A inverse we need det A. This is the process to find A inverse here. And first I am finding here det A. Det A is equal modulus of this one and this one, A plus IB into A minus IB minus of C plus ID into C minus C minus C here, C minus ID. If you take minus a common, this will become plus here. Minus I am taking minus as common here, C minus ID, modulus close here. Here it is in the form of A square A plus B into A minus B, that is equal to A square minus B square. This is the formula. This is the formula here, and that is A square minus of IB whole square, then plus C square minus of ID whole square. Now mod of A square, I square is nothing but that is plus 1, minus I square is equal to that value is minus 1, minus 1 into B square, that is B square, and plus C square, I square is nothing but I square is equal to minus 1. So that I am substituting plus D square here, and A square plus B square plus D square is equal to 1 from the given question here. Det A is equal to how much here? Mod A is equal to, or mod A is equal to 1 here, and we got det A here. Then we need to find cofactor. Cofactor matrix. Cofactor is equal, for this first element this is A minus IB, and for the second element minus C plus ID, and for third element C plus ID, and for fourth element A plus IB. And next we need to find adjoint of A. If you want to find adjoint A of A, just we need to change the signs here, plus of A minus IB minus of C plus ID, and minus of C plus ID and plus of A plus IB. Now multiply here, A minus IB as is common here, and if you multiply C minus ID this is the value, and minus C plus ID, minus C minus ID, and here A plus IB. Now here we want A inverse is equal to 1 by det A is nothing but 1, and the adjoint A is, this is adjoint A. Let's substitute the matrix here, A minus IB, here C minus ID, and minus as common, C plus ID and A plus IB. This is the final solution for this matrix, this question here. And the third question is, if A is equal to, is given one matrix, if A is equal to, is given one matrix, that is 3 by 3 matrix, 1 minus 2 3, 1 minus 2 3, and 0 minus 1 4, 0 minus 1 4, and minus 2 2 1. This is the 3 by 3 matrix. Then find, he is asking to find A dash whole inverse, A dash whole inverse. Now first here solution for this one is, here A is equal to, he is given 3 by 3 matrix, then he is asking to find A dash whole inverse. A dash is nothing but transpose of a matrix, then for that transpose we need to find the inverse here. First A is equal to, I am taking 1 minus 2 3, 1 minus 2 3, here let me check the question is correct, 0 minus 1 4 minus, okay fine, minus 2 2 1, and for this one the A dash is, A dash will become changing of rows into columns or columns into rows. So I am changing 1 minus 2 3, 0 minus 1 4, and minus 2 2 1, and this is the A dash. Now for this one we need to find inverse. So det of A dash, det of A dash, I am finding det of A dash mod of 1 into minus 1 into 1 minus 1, 4 to the 8, and minus 0 into minus 2 minus 6, minus 2 plus 2 is nothing but, here minus 2 is there, so minus 2 is the value. Eliminate the row and column here, minus 2 into minus 4, minus 2 into 4 minus 8, minus 2 minus become plus 3. Now 1 into minus 9 plus minus 0 minus 2 into minus 5, this is equal to minus 9 plus 0 minus into minus become plus 10, and plus 10 minus 10, that will become 1. Here det of A dash is equal to, det of A dash is equal to 1, or mod of A is equal to 1 here, and here we got mod of A dash here, sorry, A dash is equal to 1. Let's find cofactor of A dash, cofactor of A dash. Now, and for this one, for 1 minus 1 into minus 1 minus 8, minus 1 minus 8, and for 0 minus 2 minus 6, minus 2 minus 6, and for minus 2 minus 8 plus 3, minus 8 plus 3. I am directly solving here, I am not explaining any complete calculations here. So directly I am substituting, and for minus 2 here, eliminate the row and column here, 0 minus 0 minus into minus become plus 8, directly I am writing here, and for minus 1 minus 6, 1 plus 6 here, 3 to the 6, and for 2 4 minus 0, 4 minus 0, and 4 for 2 4 minus 0, and for 3 0 plus 2 here, and for 4 2 plus 4 here, 2 minus into minus become plus minus 4 here, and for 1 minus 1 0, minus 1, 0 here. And this is cofactor. Next, let's write cofactor of A dash. Cofactor of A dash it is. Next, minus 9, minus 8, minus 5, 8, 7, 4, 2, minus 2, minus 1. And here we want adjoint. Adjoint is nothing but signs changing here. Plus minus of minus 8 plus minus 5 and minus 8 plus 7 and minus 4 and plus 2 minus of minus 2 plus minus 1. And now adjoint A will become minus 9, minus into minus become plus 8, directly I am writing 8 here, and minus 5, minus 8, 7, minus 4, 2, minus into minus become plus 2 again, and minus 1. This is adjoint A, and we need A dash, adjoint of A dash it is. We need A dash whole transpose, A dash whole inverse here, then 1 by det of A dash into adjoint A dash. Now 1 by 1 is the det value, and adjoint of this matrix is minus 9, 8, minus 5, minus 8, 7, minus 4, 2, 2, minus 1. This is the final answer for A dash whole inverse. This is all about the question. First I am finding A dash for the given matrix and finding determinant of det of A dash, that is 1 here, and then I am finding cofactor of A dash. After finding cofactor, I am finding A adjoint of A dash by changing of signs alternatively, and after getting adjoint of A dash, I am substituting det of A dash and adjoint of A dash in the formula of A inverse. This is all about the third question, and the next question is fourth question is given. If A is equal minus 1, minus 2, minus 2, and 2, 1, minus 2, and then 2, minus 2, 1, then show that adjoint of A is 3A dash. Find A inverse. Here he is given adjoint of A, and he is asking to show 3A dash is equal to adjoint of A. Adjoint of A is equal to 3A dash here, and solution. Given that A is equal minus 1, minus 2, minus 2, and 2, 1, minus 2, 2, minus 2, 1. This is the given matrix here, and I am finding determinant for this one. Det A is equal I am finding adjoint of A here first. Minus 1 into mod of 1 minus and minus become plus 4, that is minus 4, and minus 2 is nothing but plus 2, it will become minus 2, and 2 minus into minus become plus 4, and directly I am substituting here minus 2 into minus 4 minus 2, and it will become minus 1 into minus 3 plus 2 into 6 minus 2 into minus 6, then minus 1 into 3, that will become plus 3, minus 1 minus into minus become plus 3 plus 2 6 ja 12, minus into minus become 2 6 ja 12, 12 plus 12 24, 24 plus 3, that is equal to modulus of 25, that is nothing but 25 here. This is det A. And now here I am finding adjoint A. To find adjoint A, we need cofactor of A, that is equal to, next for minus 1 minus of 4, 1 minus 4, and for minus 2 minus 2 plus 4, 2 plus 4. Next for minus 2, minus 4 minus 2, minus 4 minus 2, and for 2 here minus 2 minus 2 minus become plus 4 here minus 2 minus 4 minus 2 minus 2 minus 4 here, and for 1 minus 1 minus 2 minus become plus 4 minus 1 plus 4 here, and for minus 2 2 plus 4. Next, observe carefully, I am multiplying the terms, elements and multiplying symbols also. So for 2 4 plus 2 4 plus 2, and for minus 2 2 plus 4. Next, 1 minus 1 plus 4 and cofactor of this one. Next, minus 3 6 minus 6 minus 6 3 6 6 6 3, and this is only cofactor, but we need adjoint. This is cofactor. Now adjoint, what will happen here? Adjoint of A, signs will be changed. Minus of plus minus 3 minus 6 plus minus 6 and minus of minus 6 plus 3 and minus 6. Next, plus 6 minus 6 and plus 3, and adjoint of A is equal to 3 minus 6 6 minus 6 here again, this is minus 6 and 6 3 minus 6 6 minus 6 3. Here if you take 3 as common, scalar multiplication, scalar common from this matrix 3, what will happen? 1 ja 3 minus 2 ja 3 minus 2 ja 3 2 ja 3 1 ja 3 minus 2 ja 3 2 ja 3 minus 2 ja 3 1 ja. Here if you observe, this matrix is same like as A, 3 into A. I am substituting this matrix with A, so that is 3A. Then proved adjoint of A is equal to, adjoint of A is equal to 3A here. No, here first we need to find here adjoint of A is equal to 3A dash. This is A dash, not A here. This is A dash here. Now this is we proved here adjoint of A is equal to 3A dash. Now let's find A inverse here. A inverse is nothing but I am changing here. This is A inverse adjoint of A. Now we need to find the A inverse. A inverse is nothing but, let's substitute 1 by det A into adjoint A. Let's substitute 1 by det value 25 and adjoint of this matrix. You can write here. This is the solution for this question here. And the next question is, if fifth question, if A into B into C, A into B into ABC is not equal to 0, then find inverse of matrix A 0 0 0 B 0 0 0 C. And here the solution is given one 3 by 3 matrix, that is a diagonal matrix. Given that A is equal to, I am taking that is A 0 0 0 B 0 0 0 C. Now we need to find inverse. Inverse is nothing but, first we need to find det A. Det A is equal to A into mod of A into BC minus 0 and plus 0 into 0 and plus 0 into, this is minus 0 into 0, this is plus 0 into, everything will be 0, and mod of A into BC, ABC, mod of A, then ABC. Det A is equal to, we got ABC, or mod of A is equal to, we got ABC. Now let's find cofactor matrix. Cofactor matrix. Cofactor matrix is nothing but of A, that is equal cofactor A into this term BC minus 0, BC minus 0 and 0 for 0, 0 minus 0 and for 0, 0 minus 0 and for this one 0 minus 0 and for this one AC minus 0 and for this one 0 minus 0 and for this one 0 minus 0 and for this element 0 minus 0 again and for C AB minus 0. Finally, we got cofactor for this one is equal to, here I am taking cofactor BC 0 0 0 AC 0 0 0 0 AB. This is a cofactor and we need adjoint. Adjoint A. Adjoint A is equal changing of signs plus BC minus 0 plus 0 and minus 0 plus AC minus 0 and plus 0 minus 0 plus AB. Again we are getting the same one, that is BC 0 0 0 AC 0 0 0 AB. Now we want A inverse. A inverse is nothing but 1 by det A into adjoint A. So here I am directly substituting A inverse. 1 by det A here, 1 by det A, 1 by ABC into BC 0 0 0 AC 0 0 0 AB here. Now multiply this scalar multiplication to all the elements. BC by ABC 0 0 0, AC by ABC 0 0 0, AB by ABC. Then what will happen here? BC BC get cancelled, AC AC get cancelled, AB AB get cancelled. Then the final one is 1 by A 0 0 0, 1 by B 0 0 0, 1 by C. This is the final A inverse for the given question here. This is all about this session here, exercise 3E here. In next session we will discuss about the exercise 3F here. Thank you.